Hello everyone, welcome back to Algebra 1 with Miss Betsy, as today we continue our discussion of solving equations, and we're going to be dealing today with equations that look a little bit different than they've been looking so far. So if you are tracking along with me, we are of course in Algebra 1 for Christian schools. It's the second edition published by Bob Jones University Press. Third edition, the tracking of the sections is very, very different. So let's go ahead and pray, then see what my lame joke is for the day, and then we'll dive right into the material. Father, I'm thinking of how grateful I am for the huge advances and increase in technology over my lifetime. Father, I'm grateful for the opportunity to be able to teach my kids and actually others from around the world from the comfort of my dining room. Father, I ask that you would help the kids to understand those things that I am attempting to teach. Help them speak clearly and help them to apply themselves diligently to your work. And I pray in the name of Jesus. Amen. Okay. Oh, this one's really bad. What did the frog order from the drive-thru? You know, of course, he's driving his car through the drive-thru, and what did he say? Well, he said, "I would love to have an order of flies and a large Diet Coke, please." So, section 4.5 is equations of the form ax plus b is equal to cx plus d. And you think, oh, that's really like a whole bunch of weird letters now, Miss Betsy. This is just the pattern or the template for the equations that have this form up here. And what do you see that's different about them from the equations that we've been working with so far? Well, the only real difference is that you have variables on both sides of the equation. Variables on both sides of the equation. And since we're trying to isolate the variable on one side of the equation, this of course does present a bit of a problem. So what we need to do is move the variable ones from one side of the equation to the other. Let me read your book from page 147. Move the variables to one side of the equation and all other terms to the left-hand side. And how are we going to do this? This is their written answer, and then I'll illustrate it for you, and I think it'll make better sense. To place all the variables on the left, you must eliminate the x on the right. Remember, the coefficient of the x term is plus 1. To eliminate x from the right side, subtract x from both sides of the equation. And they're talking about this first example here. So, we have 2x plus 5 is equal to x minus 2. And we have been accustomed, as we've been going through our work, to having our variable on the left-hand side of the equal sign and our constant term, or the solution, on the right-hand side of the equal sign. So what your book says is, okay, we don't want that x to be over here. We want our constant terms on the right, and we want our variable terms on the left. So you can think of this, you know, x is just 1x, that there has been 1x added to the right-hand side of the equation. So, let me go ahead and do this. X, and I want to follow exactly where they locate it, x minus 2. All I did was add some space in here for my red marker. What do we have here? We have an x that has been added to the right-hand side of the equation. What's the inverse of addition? Yeah, it's subtracted. So we're going to subtract that x from the right-hand side of the equation because we don't want any variables. We don't want any letters on that right-hand side. To keep our equation in balance, however, you have to subtract x from this other side of the equation as well, because you have to keep that equation in balance by performing exactly identical operations on both sides of the equation. So what do we have now? We have 2x minus x is x. Plus 5 is equal to, we're going to collect like terms again. X minus x, they go away at 0, is a -2. Now, look. You are right at the form of an equation that you are very well accustomed to. We want to isolate that variable. What's happened to it? 5 has been added to it. So what is the inverse of addition? Subtraction is the inverse of addition. So we have x plus 5. We're going to subtract that 5 from both sides of the equation this way. And what do we get? X plus 5 minus 5 is x plus 0, which is x. -2 minus another 5 gives us a -7. Do you think that's the right answer? Well, let's check. 2 times a -7 plus 5, is that the same as -7 minus 2? Well, what's a -7 minus 2? That's a -9. 2 times a -7 is a -14 plus 5 is in fact equal to -14 plus 5 is equal to a -9. And this is all that you need to do that's a little bit extra. It's a new step that has been added in this section, in that you have variables on both sides of the equation. And you just need to remove the variable so that you've got from one side of the equation. Typically, people move that variable or eliminate the variable on the right-hand side so that all of the variables are on the left. So let's go ahead and look at our next example here. We have 3 times the quantity x minus 4 is equal to 4 times the quantity x minus 6. What's our order of operations say? Our order of operations says that if you have parentheses, you have to remove those parentheses first. So what are we going to have to do here as I recopy this problem? Well, ideally, you would work inside the parentheses first, wouldn't you? But you cannot, variables and constants are not like terms, so you're going to distribute 3 times x minus 3 times 4, which is 12. You could also write this 3x plus a -12 when you do the distribution. Whichever of these two forms here makes the most sense to you, that you're most comfortable with, go ahead and use that approach. 3x minus 12 is equal to 4x minus 24, or 4x plus a -24. Now, let's go ahead. We said we could move the variable to the right or the left. And they want to move the variable to the right-hand side, meaning that we want to have all of the variables on the right, the constant terms on the left. So what has happened over here? They've added a 3x to the left-hand side of the equation. So they're going to subtract 3x from the left-hand side of the equation. And then, of course, they're going to have to do the same thing on the right-hand side of the equation to keep everything in balance. And you'll notice that I put this -3x in the middle. Doesn't matter. Remember, addition is commutative. You can change the order around, and it doesn't affect the outcome. I just like to have my variables next to one another. 3x minus 3x is a -12. 4x minus 3x is x minus 24. We don't care about x minus 24. We want to isolate that x, get it all by itself. So what are we going to do? Well, what happened here? X had 24 subtracted from it. The inverse of subtraction is addition. So we are going to have to add 24 to both sides of that equation. x minus 24 plus 24. Negative 12 plus 24 is 12. Negative 24 plus 24 is 0. So we have x is equal to 12. And you notice I said x is equal to 12 even though it says 12 is equal to x. Seesaws have the same value regardless of, or equations have the same value regardless of what order they're in. You say, well, yeah, but I'm just not real sure I trust you. What if we had, instead of having the variable be on the right-hand side, what if we had it be on the left-hand side? Would we still get the same answer, Miss Betsy? Well, let's see what we get over here. And I'm going to just begin at this point where we've done the distribution. And we have 3x minus 12 is equal to 4x minus 24. So we're going to eliminate the variable on the right-hand side. And how are we going to do that? Well, 4x has been added, so our inverse says we're going to have to subtract 4x from both sides of the equation. Not 14, I have no idea where that came from. Subtract 4x minus 12 is equal to 4x. Remember, I'm just copying this here. I have to subtract a 4x from both sides of the equation. Minus 4x is equal to, minus 24. Now, let's collect like terms and see what I've ended up with. 3x minus 4x is a negative x, minus 12 is equal to 4x minus 4x is 0. So we have negative x minus 12 is equal to a negative 24. Now, we're trying to isolate the variable, aren't we? So we have, what's happened to the x? It's had 12 subtracted from it. So we have negative x minus 12. What is the inverse of subtraction? Well, the inverse of that, of course, is addition. So we need to add 12 to both sides of the equation. Negative 24 plus 12. Now, we can see what happens. Negative x minus 12 plus 12, that goes away. Negative x is equal to negative 24 plus 12 is a negative 12. What do? I don't care about a negative x, I want an x. Well, that's actually negative 1x. So if we divide both sides of this equation here by a negative 1, what are we going to get? Divided by a negative. Negative 1 and a negative 1. Negative divided by negative gives us a positive. And now we have x is equal to negative divided by negative is a positive. We have x is equal to 12. And you see that you do, in fact, get the same value for x if you isolate the variable on the right-hand side of the equation, or if you isolate the variable on the left-hand side of the equation. You can do whichever one makes the most sense to you. I like to move my variable so that I will end up with positive variable. Like here we ended up with x being positive here, so I didn't have to divide by a negative number. Here I ended up with a negative x, so I had to divide by a negative number. And that's an unnecessary extra step that if you order your work carefully, you don't have to worry about dividing by negatives. And you'll hear me say all the time that negative signs are some of the biggest problem causers of anything in math. People forget how to multiply with them, or you drop a negative sign and your answer's off simply because of that negative sign. Now, the bottom of Page 148 says what you do to solve equations that look like this. Obviously, you're going to remove parentheses and you're going to collect like terms. Second step, use inverse operations to move the variables to the desired side of the equation. You pick. Doesn't matter if that variable is on the left or if it's on the right. You pick which side of the equation you want to move the variables to. But realize you can only have variables on one side of the equation. And then you solve the equation. Here's one final example. 5x plus 3x minus 4 is equal to x. I'm glad I checked because I didn't think there'd be 2x minus 2's. 5x plus 3x minus 4 is equal to x plus 2. What are we going to have to do? Well, we have to combine like terms first, don't we? 5x plus 3x is equal to 8x minus 4 is equal to x plus 2. We have variables on both sides of the equation. The larger number is on the left. So I'm going to eliminate the variable on the right. How am I going to do that? Well, what's happened over here? We have a plus x, or a positive x. The inverse of addition is subtraction. So I'm going to subtract a single x from both sides of the equation. So there's my minus x here. Minus 4 is equal to plus x, or is equal to x minus x plus 2. And then we're going to go ahead and simplify and see what we end up with. 8x minus x gives me 7x minus 4 is equal to x minus x is 0 plus 2. It's looking much more normal, very manageable now. We still have 2 more steps. First, x was multiplied by 7, and then 4 was subtracted from that product. So we use inverse operations in reverse order. The inverse of subtraction is addition. So I have 7x minus 4, and I'm going to add 4 now to both sides of that equation. And I have to make certain that I add to both sides of the equation because that equation has to remain balanced. Plus 4. Let me check my answer here. Okay. Now, see what happens. 7x minus 4 plus 4 is plus 0. So I can just say 7x is equal to 6. And now we only have one operation left. What's happened to the variable? It's been multiplied by 7. The inverse of multiplication is division. So we're going to divide both sides of this equation by that coefficient there, which is 7. Your 7's cancel. And we have x is equal to 6 over 7 as being our solution. You could take the time, go back in there and verify by checking that your answer is correct, but I'm not going to do that on this video. So take your time when you're working with solving equations that involve variables on both sides of that equal sign, but it's not hard. It's just the problems are getting a little bit longer because you have more and more steps involved. And I think already you can see, even with an example as simple as this, why I'm saying, yeah, so I'm glad that you know if you have x plus 3 is equal to 4, that x has a value of 1. But you get to equations where it's a lot harder for you to look at it and say instantly what the answer is. This is why you need to be able to understand and clearly write out all of the steps that you're using. Send me a text if you have difficulty or ask me a question on Friday. Otherwise, I will see you next time.